My name is Graeme Rocher. I am an architect at Oracle Labs and have been since 2020. I created another framework, which some of you may have heard of, called Grails, a little while back, and then subsequently Micronaut. You can connect with me on social. My surname is Rocher. It's my grandfather's name was Jean-Pierre. Unfortunately, the French language didn't propagate to me. I can only apologize for that. So this session will be in English, but hopefully you'll be able to answer any questions. I think Cedric is in the audience around any kind of support. So a little bit about the Micronaut framework. It is a Java framework that was created about 5-6 years ago now, I think. And it works very differently to the way traditional frameworks like things like Spring work, in that it plugs into the Java compiler via annotation processes. The point of moving all this processing to compilation time is to avoid some of the common patterns required to build frameworks like Spring. So in the case of Micronaut, we completely remove the need for things like reflection, dynamic class loading, runtime generation of proxies. And the ultimate end goal is to make a low memory and high performance framework, but without sacrificing developer productivity. So we want folks to have a great developer experience. We're very focused on developer productivity and making sure you have a great developer experience when using the framework. So it's that balance act of performance versus developer productivity, which drove us to create the framework. And since then, since Micronaut came out, there's been a lot of movement in the whole Java world with other different frameworks coming out that follow similar compile time approaches. GraalVM is a high-performance JDK distribution that came out of Oracle Labs, and it can be used like a regular JDK. And in that mode, it replaces the JIT in Java, improving throughput, reducing latency. But it's probably more famous for the native image tool, which allows you to convert your Java application into a self-contained native executable. Now, that is done through a process called a closed world static analysis. And I mentioned how Micronaut gets rid of reflection, dynamic class loading, runtime proxies, etc. That greatly helps the GraalVM tool to perform the necessary analysis to create, that's allowing it to create a native image easily without feeding it any additional configuration. There's essentially two approaches to supporting native images. If your application does a lot of reflection and a lot of dynamic stuff, you can pass it the configuration needed, and GraalVM fully supports reflection as long as you pass the necessary configuration. Or you can just not do any of that and make your application compatible from the beginning, and then you don't have to configure anything. Micronaut follows the former approach, right, of just being, the idea is you should be able to just pass the application to the GraalVM tool, and it should just work without additional configuration, without generating additional configuration. The focus of this presentation is to go through a few incredible things that you can do with these amazing tools. And we're going to go through a series of fast-paced demos of the kinds of things that you can do with Micronaut and GraalVM. And the first topic we're going to look at is command line applications. So command line applications historically with Java have been a bit of a hit and miss affair. If you use Java for command line apps, then you need a Java installation on the target machine. They don't start up very fast because you have to spin up a whole JDK. But along came GraalVM, and that changes everything, right? You can create native distributions of command line apps that run on the architecture that you're building for, whether that be a Windows machine or a Mac or a Linux box. And GraalVM makes it actually realistic to build command line apps with Java. And I have an example here of a command line app. And there's a really neat framework that Micronaut integrates with called Pico CLI, which supports GraalVM out of the box. And you can define commands in an annotation-based model, where you can say things like, this is a git star command, and provide it like description, and it supports like color highlighting and completion. And you can, the cool thing by integrating with Micronaut is it lets you integrate dependency injection. So you can inject using standard Jakarta.inject annotations, any component by dependency injection into your command. And you can just decoratively define your command using, including the options it supports, in this case, a verbose flag, any other parameters it supports. And you provide a main method to start it up, and you have a fully functional command line application. Now, this command line application can be easily turned into a native image just by running Gradle W. In this case, I'm using Gradle. I have another app that uses Maven, so you'll hopefully see different incarnations. But you can just do native compile or just NC, which will build the application into a native executable. And this will perform the closed world static analysis on the application, converting it into a native binary. And because this is a Mac, this will build and it's an ARM Mac, one of these newer ones. It'll build a ARM image for this machine that I can only run on this machine. But so you do lose a little bit when in terms of application portability. That's obviously something to be aware of when you're using GraalVM Native Image, because you can't take the image built on this machine and run it in a Linux server. So typically you have to put it in your CI pipelines. But you gain so much more in terms of key aspects such as startup time. So startup time, and memory consumption, and image size. Those are the key metrics that GraalVM focuses on. So startup time is in the small number of milliseconds, and the app starts up instantaneously without you having to wait for the whole JDK to start up. It really uses very little memory. Instead of several tens of megabytes, or more than 100 megabytes in the case of Java, it'll use tens of megabytes or just a very small amount. And the image size. So in this case, we built an image, and there it is. It's Git star, and we can run it. And in this case, it takes a little bit longer. The startup time is actually instantaneous, but because this command line app is issuing a HTTP request to retrieve the number of stars from the repository, the delay is actually the HTTP request, but the application actually starts instantaneously, right? And because we're using Pico CLI, we get nice outputted help. You can generate completion for it and create really slick command line experiences with GraalVM and Micronaut. Number 2, okay, so a very cool use case for Micronaut plus GraalVM is to deploy serverless applications. Why is this such a great fit? It's a great fit because the serverless use case is very, very cold start sensitive, especially if you're exposing a HTTP endpoint, right? You want your application to come up as soon as possible to be able to serve requests, and then when it's not doing anything, to go away. Now, historically, Lambda and Java haven't been a great fit if your application was highly dependent on cold starts, because the cold start of spinning up entire JDK on AWS Lambda or any serverless environment is significant. Is significant. Then along came GraalVM, and the whole thing changed, right? Now we have this ability to deploy native executables to GraalVM, and Micronaut provides significant integration with Lambda such that you can build and publish native images and deploy them directly to Lambda. So when you create a application with Micronaut and Lambda, we will actually create a multi-project build for you. So you might be wondering, how do I create an application to deploy to Lambda? Well, you can go to start.micronaut.io and you can find the feature for Lambda. And you can even choose ARM if you want to choose to an ARM instance. And you just choose those features, and I think you can choose a CDK as well, AWS CDK. Oops. When creating your application, And by choosing the CDK, ARM, and Lambda, and the GraalVM feature, actually, no, I think Graal is just by default nowadays. You choose those three, and it will generate a project for you when you click the Generate Project that you can import into your IDE. That includes an application, which is your Lambda, and it's just a regular Micronaut application. So Micronaut has very similar programming model to other REST-based frameworks where you define, or like Spring or JAX-RS, whatever. You define controllers, you define mappings to URIs. In this case, I've got a controller that maps the home endpoint and a GET request that returns hello world. So it's like a hello world example. But the interesting part is the infra project that also gets generated. And this generates the app stack that lets you deploy your application directly to Lambda. And that means with a few simple commands, where when we generate this script as well, you just run Gradle build native Lambda and CDK deploy using the AWS CDK. Whoops. You can deploy your Lambda into remotely, and it will build a native image. It will take your application, build it into a native image, and the actual building of the native image uses the AWS Linux, the same base images that you need to deploy to Lambda, right? The exact same base images. So the Amazon Linux base images for the production environment. And it creates the native image, and it creates it by building the native image inside the Docker container, right? Which is really important because I just can't build a native image locally on my machine and then upload it to the cloud. So we have to build a native image inside of a Docker container, and then upload that generated application into the Lambda environment so it's deployed. And all of these tools are included as part of Micronaut when you create your application. So it already sets up all of the CDK infrastructure necessary for you to deploy the Lambda into the Amazon environment. And this tool chain has proved very popular. So how many of you have heard of Disney Plus, the streaming service? Okay, so the Disney Plus streaming service, the entire back end of the Disney Plus streaming service is written using GraalVM Micronaut deployed to Lambda, serverless, right? So whenever you stream anything from AWS Lambda, it's using this whole tool chain. It'll use CDK to spin up your app stack and set up all the credentials. I'm deploying to the EU central area, I think. And it will do all the business to publish your application, push it to the cloud, and make it available using AWS CloudFormation. I think hopefully it'll run relatively quickly because I think I deployed previously. But at the end of the process, basically it'll spit out the URL of where your AWS function is deployed to, your Lambda, and in this place it's setting up API gateway, deploying the application, and boom, and at the end it gives you some outputs. And you can see one of those outputs is the production URL of my AWS Lambda service, and I can click on it, and I have my application starting up instantaneously, running on Lambda with pretty much zero cold start waiting time. And the whole application is running. Okay, it's a hello world, but it's pretty slick and pretty cool. Okay, so another cool thing you can do, number 3, and we're going to have to get moving. We're rotating through these. It's mix Python and Java code. So GraalVM also, it's a whole suite of different technologies, and one of those technologies within the GraalVM suite is called Truffle. And there are various languages that are built on top of Truffle. Python, Ruby, etc. And because of the nature of GraalVM, it eliminates a lot of the cost of interlanguage communication. And that means you can do awesome things like invoke directly from Java code your some Python script. So I have an example here, which is using Python. And it's an application, just a Micronaut application, and it has a controller. And the controller exposes an endpoint. And the endpoint uses a library, a Python library called PyGal, to produce a graph using an SVG and Fibonacci, and the Fibonacci sequence. The PyGal interface, which I'm injecting into my controller here using dependency injection, is using an integration that we're working on, and it's pretty slick, where you can annotate an interface with a binding to a Python library, with the name of the Python library, and Micronaut will deal with the invocation of the actual Python library. So the whole plumbing of that is kind of a little bit hard-coded in here in terms of how it works. There's an interceptor that basically you get hold of GraalPy and invoke the method, get the Java binding for the implementation, invoke the method, etc. But the end result is we want to make it so slick that it's just like you declare interface a binding and you can invoke any Python code. So so with this, you can run, and I'm using Maven this time, run the application locally, and it'll start up. And it takes a little bit of time, the application, to start up versus a regular Micronaut app, because it spins up the whole Python subsystem. And now if we go to PyGal, my controller is invoking my Python library and drawing a nice graph for me. So that's kind of an example of direct integration that Truffle provides between different languages. And I think it's pretty slick and cool. Okay. Number 4, native Kafka streaming. Okay, so Micronaut provides some very slick integration with Kafka. And what I'm going to do here is going to I'm just going to start Zookeeper and start Kafka up. So, oops, Zookeeper is not ready yet. Hopefully this is temporary. Okay, none exists. Kafka server is down. Okay, it was just Zookeeper taking a while to get going. I think I did a kill all -9 Java before starting my demo, and killed my Kafka server and my Zookeeper instance before starting. It's always a safety net I do before presentations. Kill everything, make sure it's clean. And I happened to kill my server. Anyway, so I have here a Kafka producer, and we can open it up in VS Code just to be different. Because we have really slick VS Code integration as well. So this is a producer, and what it does is it has a scheduled job, and if on a fixed delay every 1 second, it produces it's using a library called Faker, which lets you, it's normally used for testing, where to faking data, and lets you fake names and so forth. So it's calling my producer, and I have a simple producer object here, which is a Kafka client. And Micronaut lets you declare Kafka clients on interfaces and annotate a method with @topic, with a particular topic you want to publish to. And then on the arguments, you can specify the Kafka key and the body of what you're sending. And Micronaut will deal with all the logic of actually sending out the Kafka message with the producer and managing the producers and so on and so forth. So you can, of course, use the native Kafka API if you want, and you inject producers directly and do whatever you want. But this is a very slick way to because using this model, you can apply other kind of advice and hints to Micronaut. For example, if you wanted to add retry, you could add retryable and retry the operation automatically, etc. So, and Micronaut also supports scheduled jobs. So you can, on a method, you can add a schedule at a fixed delay that executes something every 1 second. So injecting this producer and every second sending out a name of a person is what this producer is doing. Then on the other side, we have a Kafka consumer. And this guy is another Micronaut application, which just got a main entry point, and it defines a consumer. And to define a consumer in Micronaut is really easy. You just take a class, you annotate it with Kafka listener, and on each method you want to listen for a particular topic. You just define add topic and populate the arguments with the Kafka key and the message body that you want to receive. And it's really a simple programming model, and we have even more advanced cases where if you want to do rebalances and send tos to relay messages or integration with Kafka streams, this is obviously the most simple example. So with these two things in place, what we can do is we can go to my producer, or maybe we go to the consumer first. And you can, with the producer, you can basically build it into a native image, just like any other application. So I can do GraalVM Native compile and produce the native image, but I have already built a native image to save us a bit of time. There we go. So that's my consumer, listening for messages. And then I can go to my producer and run it as well. It's also a native application. And just look at how quickly these applications start up, right? That was like instantaneous. And here we have my producer. So my producer is running, sending the messages, and you can see that my consumer is now processing my messages and doing its thing. Cool thing, with these applications, so if we look at the kind of memory consumption, my consumer is consuming 13 megabyte of memory. My producer is consuming 26 megabyte of memory. So because you typically scale Kafka consumers by processors, or you can run many more consumers than you would be able to with Java. So I can start another consumer here. And my Kafka cluster will rebalance, and now we have two consumers partitioning the data and processing messages independently, right? So yeah, that is pretty slick, and GraalVM makes optimizing those applications to consume the fewest amount of resources a possibility, right? Another cool feature with Micronaut is cross-language compiler plugins. So Micronaut is a compiler plugin itself, and the whole ecosystem of Micronaut libraries is based on a common compiler plugin API, and we support different languages. So we support Groovy, we support Java, and we support Kotlin. And I think Micronaut is unique in that it's the only framework that I'm aware of, or library in the Java ecosystem, that lets you write a single compiler plugin that works across Java, Kotlin, and Groovy. So if you have that requirement, maybe not many people do, you want to write a compiler plugin that plugs into the Java compiler, the Kotlin compiler, and in the Groovy compiler or any other language, you can do that with Micronaut. And the way you do that is through the compiler API. So for this demo, what I'm doing is going to demonstrate is there is, because we were just looking at Kafka, there is a serialization format called avril. You may have heard of it. And it is an Apache project. And basically, you define schemas. And they look like this, basically. So you define a type and a type name and various attributes. Let me see if I can find some Avro schema example so that you can see what I'm saying. Basically, they look like this, right? So here's an Avro schema. You define a type, that's a record, has a namespace, has a name, and various fields. And Avro is quite popular in the Kafka world because it allows schema evolution, right? So you can define schemas, you can publish them to the schema registry with a version, and later if you change the schema, you can define a new version, and then have old messages to use the old version, new messages to use the new version. It's all about schema evolution, right? So I thought it'd be quite cool is if we could generate Avro from Java, right? So that seems like maybe a useful thing to do. So what I've done is I've written this example project here, and I've defined an annotation called I called it Avro entity. I don't know if there's a better name. It's @Avro entity, right? So it's an annotation, and I put this in one module. So typically you put the annotations in one module that both your compiler plugin consume and your kind of users consume. So it's in an independent module called Avro annotation. And then I wrote a compiler plugin. And what we basically do is define a visitor, what's called a type element visitor. And the way you do that is define a class that implements type element visitor and then a meta-inf services file that references that class. And this type element visitor, what you do is you say, I want to visit all the types whilst the application is compiling that are annotated with Avro entity. And you override the visit class method. And now you can visit what's called the abstract syntax tree of the code, right? So you can visit in the Java class or whatever it may be. So every time the compiler finds a Java class, it's going to visit the class, what's called the class element. And from that, we can call into to get all the properties of that element. So we're going to figure out what properties it has. And we're going to generate some JSON. So we're just using a map with the name and the type. We'll use the simple name of the class as the name, but maybe we want to allow customizing that later. And we map the properties to the fields in the Avro. And then we write out a meta-inf file that is the Avro file. Just use, in this case, I think it's just using Jackson to write out the file. The type handling could be better. This is obviously a prototype. And with that in place, the next step is to add the compiler plugin to individual projects. So I have a Groovy project, a Java project, and a Kotlin project. And if we look at the Java project, for example, you declare your plugin on the annotation processor class path. Remember, I mentioned Micronaut is an annotation processor, so you add it to the annotation processor class path, and you allow the project to reference the Avro annotation that you want to use. And then I can come along and I can declare like a record, for example, add it as an Avro entity. And now, if we just assemble this project, we'll see what happens. I think I already assembled it before, so we'll just assemble it again with a clean. And you can see, if we look at the build directory, generated meta-inf Avro, person.avro, and we're generating the Avro from my entity. And it's really that simple, right, to write compiler plugins. I think it's pretty cool. Now, the cool thing is that it works with Groovy. So in the same project, I'm generating an Avro file for a Groovy class. And in Kotlin as well, I think Kotlin writes out files to a slightly different place, but there it is, the person.avro. And in the case of Kotlin, it is it's using a data class, I think. But we have an API that lets you do, common compiler type tasks. And recently, in the next version of Micronaut that's coming up, 4.5, in the future, we have a new module called for generating JSON schema, and it's using this API, and it's gonna be very cool. Okay, so I'm gonna have to get moving. Expression language. So let's go to my other demo project. here. So Micronaut has, or maybe I can just use that. No, I'll go to my data demo. Right. Micronaut has a compile time expression language. So you know how I was creating like a scheduled task before. You know, jobs are essentially like defined as singleton components that where you have a scheduled task that executes at a fixed rate, say once every second. Run me, and just do. Hello. Oh, my mic went for a second. Okay, so that's how you define a scheduled job. And then the latest version of Micronaut that we just released in Micronaut 4, we added support for custom expressions. So a bit similar to Spring expressions or spell, and you can, inside of an expression, you can reference properties. So for example, if I had a Boolean paused equals false property here, and I had a getter and a setter, we could reference this and say the job is only run if it's not paused, right? And the IntelliJ has already been updated to support it, so you get completion. You can even call a method instead of using the property syntax. And the cool thing about Micronaut's version is it's completely type safe. So if I run this app, for example, it'll run fine, probably. Or I think I have something running already. But if I were to make a typo like this, for example, and I try and run it again, I'll actually get a compilation error. So that's one of the critical things about Micronaut being compile time based is we report a lot of the errors that you get automatically at compilation time whilst you're using the framework, rather than waiting till runtime when the error is more confusing, right? So we're actively checking that you're using the framework in the correct way, and you're not waiting till runtime to see incorrect uses of the framework. So I think the expression language is a pretty cool feature. And since we're looking at this app, native database applications is another very cool feature. So we have a sub-project called Micronaut Data. The whole data use case is very close to my heart because one of my favorite projects when we worked on Grails was something called GraalVM, which is lets you do dynamic finders and all sorts of things. And when we created Micronaut, we wanted to create something that has all the features of GraalVM, but without some of the performance overhead. So we created Micronaut Data. And with Micronaut Data, you can, there's various versions of it. So there's Micronaut Data JPA, which lets you use Hibernate. There's Micronaut Data JDBC, which lets you use straight JDBC. And there's Micronaut Data R2DBC if you want to do reactive. There's Micronaut Data MongoDB. We have Micronaut Data Coherence, Micronaut Data Zero Cosmos. There's different implementations of it. The most popular ones are probably Hibernate, I guess, and JDBC. Mongo as well is popular. But basically, it lets you define like a mapped entity, and you can just mark this as a generated ID, and the person can have a name and an age. And I personally like Micronaut Data JDBC, which is what I'm using right now, because it's a simple data mapper. There's no, it's just mapping SQL. It's just normal SQL. There's no session. There's like a lot of the complexity of JPA and Hibernate just goes away because there's no lazy loading. There's no proxies. It's just a simple data mapper, and it's much more lightweight. So you can define entities, and then you can define repositories, and you can say that this is a JDBC repository, and currently I'm using MySQL, so I'm going to use the MySQL dialect. You might be wondering why we specify the dialect here. So Micronaut Data, and one of the big changes we did is that it is compilation time. So we compute all the queries that you're going to execute whilst the application is compiling. And we don't wait until runtime to figure out what the queries are. So that means we need to know the dialect ahead of time. But it means we have significant performance benefits. So there's no caches at runtime. There's no computation or queries at runtime. It's much more lightweight at runtime. And there's literally like zero overhead. We did benchmarks, and you cannot get better performance writing your own query, crafting by hand, than just using Micronaut data, right? There's literally like zero overhead. And most modern IDEs, like, they have support for it. So for example, you can do find by here, and IntelliJ is like figuring out the possible queries. It works as well in VS Code. And now the cool thing with Micronaut data, and I'm just going to start my server up here in continuous mode using -t, so that it starts my application and automatically reloads it on every change. And I see my job is running, which might be a bit annoying actually. So I'm just going to pause my job, and hopefully my condition will work, and it won't keep printing out that that message, which it doesn't anymore. So my expression is working. Hey, okay. So so the cool thing about Micronaut data is, like, if you make a typo in your repo, like I said, you get a compilation error. So the framework, again, even at the data access layer, it's like actively checking that you are doing the right thing. So that you can't define methods that are not supported by the framework. It'll fail compilation. It won't let you proceed. You won't get a weird runtime error when you do something wrong. So it's the integration with the compiler that's really important. So this application is can be fully computed into a native image. So I can come in here and I can do Gradle native run, and it will compile the application into a native image, and it will execute it, and it's connecting up to a MySQL database, which I'll talk about more in a minute. And it just works, right? So it just works because Micronaut Data JDBC is fully reflection-free as a data access tool. There's no reflection required, reading and writing to the database. And you can build native images, fully native database applications. And you can test them with test containers. So, you know, my application here is building a native image, but it's also using a test container, and this is powered by a feature in Micronaut called Micronaut Test Resources. So we have built-in support for test containers and test resources, such that when you run the application, and I'm using native run here, prior to the application starting up, we spin up a MySQL container for the application, and it works with native image, right? Even though this is a native app, it's connecting up to the MySQL database container, and it just works, which is pretty cool. And it works also with native testing. So I can run GraalVM native test, or Gradle. If I run test, for example, if I open up another terminal here and do GraalVM test, it'll run my tests, and because my application is already running in the other window, it's reusing the same container, right? That's already running. It's not going to restart the container. So I can come in here and run my tests, and they run instantaneously, reusing my MySQL container that's already up and running. But I can also do GraalVM native test, and that will build my tests into a native image, and run my JUnit test natively. So I think that's pretty cool. I'm getting very low on time, so I'm going to go very quickly. You can generate OpenAPI from code. So what you may not, if I, for example, created a controller here for my API, it's called a person controller. That is an add controller that maps to the people endpoint, and then I inject my repository here, and add a constructor for it, and add a get endpoint, which is just going to return a list of people, and this is just a like simple demo here. And maybe I add another one to find a person by name, something like that. And that's gonna find an optional person by name, etc. And this is going to do return repository, find by name, like. Maybe we don't want name like, maybe we just want name. And maybe we change the return type to return optional. That'll work too. So I've defined like a basic API here. And what I'm going to do is do gradle.run-t. 4 minutes to go. And what you'll see is that when this particular application has the Micronaut OpenAPI enabled by adding the OpenAPI processes. And whilst the application has been building, if I go to a browser and we go to Swagger UI, you can see that the API for my application is being constructed on the fly from my sources. Now, the cool thing is, because Micronaut is source control based processing, if we start adding comments here, like lists the available people, list of people, we save that, it'll recompile and it will restart my app. And if we come back and we look at the description, no, not that one, this one. You can see my Java doc starts to appear in my description, which is pretty cool. So we can actually translate and figure out, and we do allow you to use Swagger annotations, so you can override whatever you want. But I think that's pretty cool, and we're basically generating Swagger at compilation time on the fly. You can open this up. You can see we actually generate ASCII doc for you for your API. So we've got an ASCII doc view of your API documentation being generated on the fly as well. And we generate the YAML whilst the application is compiling, describing your entire API. I'm not going to have time to demo number 10, but you can generate code from OpenAPI. And the way you do that is to go into your build.gradle, and if I were to uncomment this, what you have to do is, and it's the same in Maven with the Maven plugins. We have the same plugins available for Maven. You apply the OpenAPI plugin. You configure the source file of the OpenAPI you want to generate a client or a server from, and you run the build, and it will generate the sources so you can make client calls or implement server stubs from your API definition. So we have complete round-trip support for OpenAPI. Okay, so in summary, those are the 10 items that I wanted to highlight about the framework being pretty amazing, with lots of amazing things. Micronaut is incredible technology with a large ecosystem of interesting modules and integrations. It's very mature nowadays. We're at Micronaut 4.4, which just came out. And GraalVM is also sensational technology that lets you do things with Java that were not possible before. Were simply not possible. It's taking Java in places that were not viable. And everything is awesome. So try it out today. Guides.micronaut.io. GraalVM docs getting started. And thank you very much. I don't know if we may have like a minute for any kind of questions, but if any people have a question, I'm happy to answer. Any questions? Oh, there's one over there.
When you built your Lambda,
Yes.
You use Docker.
Yes.
But often we use containerized CI/CD.
Yes.
Does it work with Docker and Docker?
Does it work without Docker? Yes.
With the technology Docker and Docker, which allows you to run. Okay.
Yeah. I just did it locally, but we have Docker-based CI systems running all those builds. It's very common, especially like GitHub Actions is containerized as well, so it's very common. Any other questions? There's one in the back there.
Hello, thank you for the presentation. I just wanted to ask about the avril schema generator.
Yes.
How advanced is it? Does it handle all cases like default values or unions, and especially attributes that may be complex?
It's as advanced. I built that like this morning. so it's well actually from my this is the second time. No, it wasn't this morning, but very recently. So it's a prototype thing. We have a project which is to support generation of JSON schema, and with that we want to create like a common, more mature approach for generating Abro and JSON and everything, and implement a schema registry server component. Whoops. So that project is ongoing, and hopefully by the end of the year we'll have something more mature. This was for a demo of how to do it, how you could do it yourself, right? If you wanted to write your own. Okay, thank you everybody, and thanks for coming.